let's talk about how machines actually learn to listen. It's a really cool story, actually. We're going to go on a journey from this old, kind of clunky, mechanical way of doing things to the super seamless tech we've all got in our pockets and homes today.
I mean, have you ever really stopped to think about it? You ask your phone for directions, tell your smart speaker to play a song, and somehow it just understands you. It feels like magic, right? Well, that magic has a name. It's called automatic speech recognition, or ASR for short.
Okay, so at its heart, ASR has a pretty straightforward goal. Take what you say, the actual sound waves of your voice, and just turn it into text. Sounds simple, right? Yeah, not so much. For a long, long time, figuring out how to do that was a huge challenge. And the first solution was, well, it was very methodical.
All right, so let's dive into the classic blueprint. This is the old school way of doing things, kind of like the original recipe for teaching a machine how to listen.
So check this out. The traditional way to do ASR is basically a pipeline. A great way to think about it is like a factory assembly line. It's not one big smart brain. Nope, it's a bunch of different machines, all bolted together in a line. Each one has just one job to do, and the sound of your voice has to pass through every single station in order, without any mistakes. And here they are, all the different stations on that assembly line. First, you've got the raw audio coming in. Then, an acoustic front end kind of cleans up the signal, gets rid of noise. After that, the acoustic model tries to figure out the basic sounds, the phonemes, like the k, and t sounds in cat. But that's not enough, right? So you have a totally separate language model. This thing has read tons of text, so it knows which words are likely to come next. Then the decoder has the tough job of taking the guesses from the sound model and the word model and trying to find the best possible match. And finally, the output generator just tidies it all up into the text you see on your screen. Whew, it's a lot.
Now here's the kicker. Every single one of those parts had to be built and tweaked by hand separately. Imagine that. If just one piece of that assembly line wasn't working perfectly, the whole thing could just fall apart. It was a big deal for its time, for sure, but man, was it complicated and brittle.
So all that complexity got people thinking. There has to be a better way, right? What if we could just scrap the whole assembly line idea? What if we could create one single system that learns how to go from sound to text, all in one go, all by itself? And that question, right there, changed everything.
And that's what brings us to the modern approach, the deep learning revolution. The big hero of this story is a special kind of neural network that's just perfect for something like speech, which happens in a sequence. It's called a recurrent neural network, or an RNN. And this quote really nails why RNNs are such a game changer. Think about it. Speech isn't just one thing happening at once. It's a stream of sounds, one after another. The order matters. Cat is not the same as act. RNNs are just naturally built to understand this flow, this sequence of information over time.
So why are they so good at this? Well, a few reasons. First, they have memory. They can actually remember what was said a few words ago to figure out the word you're saying right now. Super important. Second, they process things in order, just like we do when we listen. And third, they use context from all around a word to make smarter guesses. That's how a machine can learn the difference between, say, ice cream and ice cream. It's all about the context.
But wait, it gets even cooler. The story doesn't end there. See, a standard RNN was amazing, but it was a bit like driving while only looking in the rearview mirror. It only used past information. So people started to wonder, what if it could look ahead too?
And that's the next big leap. A normal RNN listens to a sentence from start to finish, but a bidirectional RNN, it listens to the sentence forwards and backwards at the same time. By looking at what came before and what comes after a word, its predictions become way, way more accurate. It's like having the full picture.
Okay, let's bring it all home. Let's really look at why this shift from that old factory pipeline to these new deep learning networks was such an absolute game changer.
This chart lays it all out, side by side. On one hand, you have the traditional system, that clunky multi-part pipeline. On the other, you have the deep learning model, one single integrated network. The old way needed all these separate hand-built models. The new way, it just learns everything it needs to know straight from the audio. And maybe the biggest difference is context. The old systems were kind of short-sighted, but these new RNNs can understand the context of an entire sentence, which means they're way more accurate and much better at handling different accents and voices.
So, if there's one thing to remember from all this, it's this fundamental shift.
We went from a system that treated speech like a machine to be taken apart piece by piece to a system that learns to understand it as a whole, all at once. It's a much more natural, almost organic way of learning, kind of like how we do it.
And that really leaves us with a pretty big thought, doesn't it? This whole journey from just sound waves to actual text, it's a massive leap for AI. It's learning to understand language, one of the most human things there is. So it really makes you wonder, now that AI can truly listen, what's the next uniquely human thing it's going to learn?